Hi everyone, I hope you're all doing well. So in today's video, I'm actually going to go through the 2017 Specialist Mathematics Exam 2 for the Northern Hemisphere multiple choice section. And yeah guys, like always before I start this video guys, if you guys want private tutoring in Specialist Mathematics, mathematical methods, physics or chemistry, you can always email me through this email. And yeah, let's start through this video. So question 1, the number of asymptotes of the graph of the function with the rule of f of x is what? Okay, you could normally graph this function, but what you can do is, okay, let's go on our calculator and have a look at this. If I write expand this function, so x to the power 3 minus 7x plus 5 x squared plus 3x minus 4, enter, we get this beautiful, proper fraction equation. So we can straight away see that we will have an oblique asymptote at y equals, x minus 3. So yep, this one over here. We will also have an asymptote at x equals 1 and x equals negative 4. So we have 1, 2, and 3 asymptotes. So yeah, D would be the correct answer. Question 2. The equation x squared plus y squared plus 2ky plus 4, where k is a real constant, will represent a circle only if what? Okay, I don't like this equation because it's not as simple to understand the circle. For example, it's not like x squared plus y squared equals the r or the radius. So let's just transform this into that kind of notation. So we have x squared, we'll keep that there. So let's write the x squared down here. This over here, I can actually change it by completing the square. So let's do that. So what's b over 2 squared, which is 2k over 2 squared, which is k squared. So we can write this as plus y squared plus 2ky minus, plus k squared minus k squared plus 4 equals 0. And we can write this as x squared. We'll leave it down there. Here, now it's a beautiful, we can easily factorize that as y, a perfect square, so y plus k squared. And we bring this over here, because this is a constant, we'll bring it to the right. So now it's much of a nicer, to see if it's a circle. So what can we see? Well, okay, your radius must always be greater than 0. That's true. If the radius is less than 0, it doesn't make sense. So for a circle to be true, we want this over here to be greater than 0. So if we say k squared minus 4 must be greater than 0, let's sketch that. Looks like this, where this is negative 2 and this is 2. Hence k can be less than negative 2 and k must be greater than 2. Which one does that have? D would be your answer here. Yeah, don't worry about this. Well, here, because if you have, any values of k, it will still represent pretty much a circle. So it's only this over here. The radius must be always greater than 0. Nice. And if you guys don't know actually how to do this, like for example, you were in an exam and, you're too kind of tired or confused, what you can do is just graph it and, sub in some values. Let's try that. So if I go on menu, graph, relation, and write this whole equation in, x plus y squared plus 2k times y plus 4 equals 0. Okay, so the first condition says that k is greater than 2. Let's check that. Yes, so when k is greater than 2, we always have a circle. But that's also false, because even at k less than negative 2, we will always have a circle too. So A and B are wrong. C is saying that k can be anything except, 2 and negative 2 and 2. Well, for example, yes, but remember, even at, from negative 1, 0, 1, we still don't have a circle, so that's wrong. Now, what our answer was k is less than 2, which is true. So when k is less than 2, we'll always have a circle. And also at k is greater than 2, we always have a circle. So that's true. D would be your answer. E in the other case is saying it's only between negative 2 to 2, which is false. As you can see, from 0, 1, there's actually no circle. So yeah, D would be your answer for that one. Question 3. For the function f of x where k is equal to arctan this, where k is greater than 0, c is greater than 0, and a and b are elements of all reals, f of x is greater than 0 if what? Okay, to do this kind of question, what I like to do is, okay, let's sub in some values. Like, let's look at the first condition. We're saying that c is less than k pi over 2. We know that k is greater than 0. For example, let's sub in k equals 1. So when k is equal to 1, our c value, so we get pi over 2. We're saying that c must be less than pi over 2. And let's try to do that. So let's actually graph this whole thing here. So if I go graph, and we're graphing k times tangent a times x minus b plus c. We graph this? All right. So we said that k is 1, and we, a and b are all elements of rho, so they can be also 1. And what about c? We said c must be less than pi over 2, so let's try to put those to the negative. Absolutely wrong. When c is less than pi over 2, we are getting f of x to be less than 0, but we want f of x to be greater than 0, so that's wrong. What about the next case? Let's try to look at this. Next case states that c must be greater or equal to, because we took k as 1, so it'll be pi over 2. Let's try to do that. C is greater or equal to pi over 2. So to check that, what I'm going to do is, okay, let's say this here is pi over 2. All right. So, okay. So when c is greater or equal to pi over 2, what are we getting? If we go to the, if I write this as, because it's c greater or equal to pi over 2, so what about pi over 2? Okay, so that's true. It's never touching. C is always greater than pi over 2 because there's an asymptote at y equals 0. So that looks good. And when c is greater than pi over 2, let's check that. It will always translate up. And having any values of a and b doesn't really affect it. For example, if I have negatives, whereas b is this, I will still have this still not going below. So f of x is always greater than 0. So b looks very right. So we'll put a dash on that. The next case is x is greater than b over a. What? So that really doesn't make sense. For example, we chose b equals 1 and a equals 1. So we're saying that x is greater than 1. Really does not make sense. X is greater than 1. No, the whole equation is all real. So that's rubbish. What about the next one? C plus k is greater than 2. So, okay. We took k as 1. So it's just saying as c, rewriting this one, is c is greater than pi over 2 minus 1 in other words. So let's try to check that too. For example, if I take this over here, pi over 2 minus 1. Okay. And let's try to check that. So c is greater than that value, so no. So we are still getting f of x is less than 0, so that's rubbish. What about the next one? C is greater than pi over 2. So if c is greater than pi over 2, so if c is greater than pi over 2, but it's not affected by k, so we can say k is 3 or something. If we go, c is greater than pi over 2, we still have f of x is less than 0. So the only possible answer would be b. So choose b as your answer for that one. Question 4. If sine this is equal to a and sine this is then, what's sine theta cos theta equal to? Okay, nice equation. So what I'm going to do is I'm going to write this as compound angle formula. So I know that sine theta plus phi, well, let's write that nice. So phi is equal, by using your formula sheet, you know that's going to be sine theta cos phi plus cos theta sine phi. And so that's all equal to, that's all equal to a. And we know that sine theta minus phi is equal to sine theta cos phi minus cos theta sine phi should equal to b. So okay, we want to find sine theta and cos phi, so this one over here, they both have it. So what I can do is, what about if I just let x equal sine theta cos phi, and y as, in this case, we'll let it as cos theta sine phi. So we can write this expression over here as x plus y equals a, and the other one's going to be x, all right, minus y equals b. And we want to solve for x. So if we add these together, those y's cancel out, so it'll be 2x equals a plus b. Hence, x is a plus b over 2. So our x represents this, so that's your answer. Which one would it be? E. Question 5. Given that a and b and c are all non-zero rational numbers, the expression this can be represented as a partial fraction form as well. Nice and easy. So I know for a fact that this over here can be written as, because it's linear, it's a over x, plus, because this one's squared, we can write it as b over x minus 2 plus c x minus 2 squared. So yeah, perfect. So which one would that be? C would be the answer for that one. Yeah, nice. Question 6. The relation that defines the line S above is what? Okay, so it's a straight line and it passes through this point. So it's y equals negative x. And have a look at these. This straight line, we can just use the perpendicular bisector. We don't actually have to, let z equal. We just have to use perpendicular bisector over here. So, for example, this over here, this point, we can write it as negative 2, 0. And this point here would be 0, negative 2. And, okay, so what does that tell us? So, this point over here is over here, right over here. And 0, negative 2 is over here. The perpendicular bisector tells us that if we draw a line like this, the midpoint, for example, the midpoint's over here, yeah? Imagine drawing a line forward through it. This is what it will represent. So this whole equation will represent this equation, which is just y equals x. So that's wrong. We want y equals negative x. So that's pretty much A is wrong. So yeah. The other one says the argument of z is equal to 3 pi over 4. This is array. This is rubbish because if it was array and it's at center 0, it would have had a open circle. So that's also wrong. So let's not keep that. What about the other one? Okay, this is a straight line also. So what other points? Well, it will be 2, 0. So 2, 0. And this one over here would be 0, negative 2. So it would be around 2 zeros here. So right over here. And 0, negative 2 is over here. So the midpoint is over here. And if you were drawing a straight line, perfect, which is y equals negative x. So C would be your answer there. And yeah, you can try the other ones in your, calculator and stuff, but it's not worth it. So what about this one over here? Let's try this one too. Because it's a straight line. We can write it as 2, 0. And 0, 2. Let's try that one. So here. And here. So the perpendicular bisector would be right through this, which is y equals x also. No, that's wrong. So your answer, possible answer would be C. That's good. That's nice. Question 7. Okay, this integral sine to the power 3 cos squared equals what? Alright, what I'm going to do here is, okay, I'm going to change this sine to the power 3 just to, for example, I'm going to write it to as sine x, sine squared x, cos squared x. This over here, I'm going to change it to using my formulas. Like, I know that the expression is pretty much like 1 minus cos squared x. Cos squared x. Okay, now we can actually let u equal cos of x. Hence, dx is 1 over sine of x du. So writing this whole integral, so pi over 4, if I sub in pi over 4 into this one over here will be 1 over root 2. And if I sub in pi on 3, it will be a half. Yes. And writing this whole expression, down, we got sine of x. Because we let u equal cos of x, there will be 1 minus u squared, multiplied by this over here, which is negative 1 over sine of x du. And these cancel out nicely. So this whole expression can be written as 1 over root 2 half u squared minus u to the power 4 du. So which one does that look like? So again, we let u equal what? Cos of x. So that's wrong. It's wrong. So it looks like B would be your answer for that one. Nice. Perfect. Yep. Question 8. The differential equation that best represents the direction field above is what? I would be honest, if I was in the exam, I would just pick a point and trace it and use my graphing calculator, CAS to do it. But I just want to first show you to understand the conceptual understanding, I want to show you how to really look at this. Okay, so you have this graph over here. I'm going to pick a point that, for example, well, I can see that like this point over here, which is, 0, 1. What's the gradient? The gradient's actually greater than 0, as you can see. It's an actual upslope. So if we picked our point, which was, 0, 1. If I sub them into this, I want dy dx to be greater than 0. Let's try that. If I sub, 0 into this, and it'll be minus 1 squared, which will, again, give me a negative slope, which is false. We wanted a positive, so A would not be your answer. Next one is saying 1 y minus x. So let's try that. So 0 minus 1. Again, it'll give me negative 1 as a slope, so also that's wrong. What about C? So if I subbed in 1 squared minus 0 squared, which is 1, so that's a positive slope, that's good. What about D? So if I subbed in also 1 squared, yep, so D also works, and also E works. So, okay, now let's pick another point that we'll try to let, we can also see that even if we put like, for example, 0, negative 1, it's also still positive. So let's try that. If I put in this equation over here, we're saying 0, minus 1, so minus 1 squared, which is negative 1. So if it's negative 1, we're saying it's a downslope, so that's C is not that one. What about D? So if I subbed in, so it'll be 1 minus 0, which will be positive, so D is good. And what about E? So we said negative 1 plus 0, which will be negative gradient. Rubbish. Again, we have a positive gradient, so only possible answer would be D. Again, you can also do this easily by CAS. If this is a very typical exam question. To do this by CAS, what I would do is, okay, let's pick a point. For example, I'm going to put, pick this point, which is, actually, we'll pick 0.5. And I'm just going to follow this field line. It goes like that, like this. Follow it. Just keep following it. And that's it. Now, if I go to my CAS, for example, go to my CAS and go on graphs, go on menu, go to graph entry, and go to differential equation. Just change this to, okay. So what we want, the equation, what we picked was y squared. So y squared minus x. And the point was pretty much 0, 0.5. Enter that. Aha. Same as our equation. Well, just let's put this as 2 over here. Put this as 0. Put this as negative 2. And put this as 2. Pretty much the same as our, like if you can't zoom out, pretty much looks like our graph. A nice representation, yeah. And you can also sketch the other graphs. For example, let's try the point x minus y, like the first one, which is wrong. But what do we see? Well, that's rubbish. That doesn't look like our graph. What about the next one? You can y minus x. Also rubbish. Well, close to it, but it's supposed to be curving upwards at the end, so that's rubbish. Next one is y squared minus x squared. This one's quite rubbish, to be honest. It's going up, so what about y squared minus x? Which is our answer. So what about y plus x? Also, this one's rubbish. So yeah, the only possible best answer would be y squared minus x. As you can see, it follows what we just drew. So that's it. Question 8, that's it. Question 9. It says that the gradient of a tangent to a curve at any point x and y is half the gradient of the line segment joining P and the point Q. Find the coordinates of the points of the curve satisfy this differential equation. Okay, the gradient of the tangent is what? To any point x and y. It's just dy dx, yes? It says it's equal to half the gradient, so half of the gradient line segment, so 2 points. So we're going to have to use y2 minus y1. So what's our, in this case, what's our y2? We'll call this y2. And so this is x2, x1, y1. So it'll be 1 minus y over negative 1 minus x, which will give us y minus 1, x plus 1. Which one does that look like? dy dx is... Looks like E would be your answer for that one. Yes. Not too bad. A solution to this differential equation, dy dx is this, can be obtained from what? Okay, so I'm just having a look at the answers. So I know that these y are being split, so I think we'll split these apart. And they're all in terms of x, and not in terms of, x plus y. So I think we'll use our compound angle formulas to separate these. For example, cos x plus y minus cos x minus y. What's that? So cos x plus y is just going to be cos of x, cos of y, minus sine of x, sine of y, minus cos x minus y, which is cos of x, cos of y, will be plus sine of x minus, actually sine of y. Yep, so kind of this all will be because of x, cos of y, minus sine of x, sine of y. Well, I'm going to let this one over here just to make easier simplification. That's x, and this one here, it's going to let it y, so it'll be x minus y minus x plus y, which gives us x minus y and minus x minus y minus 2y. So it'll be written as dy dx negative 2, and we know y is just sine of x, sine of y, all over. I want to split these apart, so it'll be etx times e to the power y. Alright, so this is much simpler to look at, so that's good. Let's delete those. Now let's have a look here. We're going to have to use separation of variables here. So if I write this over here as e to the x multiplied by sine of y, I can use separation of variables, so the integral of the inverse of this, which will be just the ey over sine of y, dy is integral of negative 2 sine of x over e to the x dx. Which one looks like that? Looks like A actually is our answer here. The other ones look wrong. Okay, that's good. 11. Two particles have positions this and that, where t is greater or equal to 0, where b is a real constant, where particles will collide if the value of b is 1. So for a particle to collide, what we want is, we want this x component to be equal to this x component, and this y component to be equal to this y component. So, what I would just do here is just use my CAS. I mean, that's the most possible fastest way. So go to your CAS and you say, go on menu, go to algebra, solve systems equations. We want to solve for b and t. In this case, so it's b and t. And we have, so, equating our x components, we get 3 minus 4t squared is equal to 5t squared. And the other one is t plus b is equal to t squared minus 1. And we solve this and we get all these values. But, of course, t is greater than 0. I forgot to kind of keep that. So it has to only be this one here. So, yeah, which one has this one? So it'll be negative 2 minus root 3 over 3. So D is the answer for that one. Looks like perfect. If U and V then the vector resolute of u in the direction of v is what? Nice and typical question. So we know that's going to be u dot, v over v squared of v. So what's u dot v? That's just 3 times 2, which is 6, plus 6 times 2, which is 12, plus negative 2 times negative 1, which is plus 2. And that's going to be 20. And what's the absolute value of v? It's going to be the square root of 4 plus 4 plus 1, which is 3. And imagine squaring that, and that's going to give us 9. So imagine squaring that. So yeah, it'll be 20 over 9 multiplied by the vector v. And what's v? It's just 2i plus 2j minus k. Looks like b would be your only typical answer for that one. That's good. Question 3. Let O, A, B, C, D be a right square pyramid where A is this, B is that, C is that, and D is that. An equation correctly relating these vectors is what? Okay. So the first one tells us that A plus C. So this is your A vector. So we're assigning this vector plus C, which C is this over here. If I'm adding these two vectors, I want to bring this to the end corner over here. This will result in this vector being made, the red vector. So this vector. So that's good. And that vector, red vector, should equal to B plus D. So let me just rub this whole out and keep that red vector in there. So it says B, which in this case is this over here, plus D, which is this over here. So if I bring this over here, pretty much over here. Aha, look at this. They are intercepting each other. So that's a vector. So can you see how they actually intercept? That is a right statement. So that's good. That's all right. That's it. Let's try the next one. So A minus C, for example. So the vector A, we'll write it as like this. Minus C. So we know that this is C over here. So this is C. But if, we want to minus it, it will just be pretty much like this. So in other words, A minus C would be like pretty much like this. Put on the corner like that. So what does that give us? This. So it will give us this vector. That's okay. Let's try the next one. So the next one states that D minus C, sorry, D, which is this one over here, minus C. So C is this. And imagine I was minusing, so it will be right on top of it. So it will have like this. Now, are they right angle to each other? So this red vector, is at right angle to each other? Well, can you say that? I don't think so. They don't look very pretty much right angle to each other. Yeah, they look very much, it's like less than 90, but well, we'll keep that as also, put a question mark. So I know A is absolutely right because they were on top of each other. Wow, this question's quite, yeah, A plus D. So A plus D is this vector over here, plus D, which is this vector. So imagine taking that vector over here, putting it right over here. Okay, that's an ugly vector. So it means it's going from here to here. It's that blue curve. All right. So that. Okay. And so that should be equal to B plus C. So B is this, plus C is this. Putting that together. Absolutely, they are not equal. Those vectors are not equal. The the pink and the blue. So that's rubbish. So yeah, that's how I would approach this question. It's a very I just want to really I know for a fact A in an exam you would just pick A, but I want to make sure to show you how you do these questions. So A minus D. So A is this vector minus D. So D is that. So over here. For example, A minus D, you put it over here, but it's because it's minus, it's going to go over here. So it will result in a vector like this. it's multiplied by c minus b, so c is this minus b. So if I take this over here, which I would normally put over here, but once it's minus, it's going to look like this. It will look like this. They're kind of in a straight line, so if you're multiplying both of them, they don't actually right angle to each other, so that's not absolutely, the dot product is not going to be 0. And the last one is just a plus b, so let's do the last one at least. A plus b, so this is a, this is b, well, that's b. Taking this one over here, gonna go right over there, hence your from here to here, that's that, and then that should equal to c plus d. So c is this plus d, which is this over here. If I take this vector and put it right over here, they are not absolutely equal. They're not equal. So the only possible answer that is 100% true is A. Alright, that's it. That's okay. 14. Given that the vectors A, B, and C is that are linearly dependent, the value of this is what? Okay, nice and easy. So I'm just going to say let alpha be vector A, so 1, 1, negative 1, plus beta is 2, negative 1, 2. It's equal to your C vector, which is this, negative 1, 4. Pretty much expanding those, this will give us this equation over here. Will also give us this equation over here. And it'll also give us this equation over here. So we have all these equations. If I add equation 2 and 3, I get beta is equal to 3. And pretty much putting into one of these equations to find alpha, we know alpha is just going to be negative 1 plus beta. So we're saying alpha is equal to 3 minus 1, which is 2. So alpha is actually 2. And putting all those values into the equation 1 to get this one over here, lambda, it's going to be 2 plus 2, 3, which is 8. You should choose 8 as your answer. Question 15. A particle of mass 2 kilogram has an initial velocity of this. After a change of momentum of this, the particle's velocity is what? So what's the final velocity? We know that the change in momentum, so the change in momentum is just mv minus u. So if we know that the change in momentum is 6I minus 2j is equal to your mass, which is 2, your final velocity is what we're trying to find, minus your initial, which is I, minus 6j. This here we can write as 3I minus j is equal to v minus I plus 6j. So v, your final velocity is going to be 4I minus 1 minus 6, so minus 7j. Which one does that look like? Looks like C is your answer for that one. Nice. Question 16. This is a person of mass m kilogram carrying a bag of mass m is standing in a lift that is accelerating downwards of mass a. The force of the lift for acting on the person has a magnitude of what? So if I was drawing a diagram over here and saying, alright, so if I just take this whole thing and just bring it over here. Imagine this over here is the person and the bag. So it's going to have a gravitational force of the mass of the person and the bag, g. There's also going to be a reaction force, that is the force is pushing upwards, is what we're trying to calculate actually. The reaction force. The force of the lift floor acting on the person. And because we know it's accelerating downwards, we're going to take the downwards as positive. So we know from the equation F is equal to ma. The net force in this kind of question is what? So our net force is m plus m g minus n is equal to the mass, so both of the masses, so which is still m plus m, times the acceleration. So what's our n? So our n is just m plus mg minus m plus m A equals n. Hence, we can take a common factor of m plus m. So m plus m is g minus a, which is E. Question 17. The acceleration of a particle moving in a straight line is given by this, where v is the velocity of the particle at any time. The initial velocity of the particle when at origin is this. The displacement of the particle from O when its velocity is 3 is what? Okay, so I know that the initial velocity, so the initial velocity at the origin is 2. So when x is equal to 0, it's 2. And we have this, and the acceleration we can write out as v dv dx is equal to v squared plus 1. So therefore dv dx is just v squared plus 1 over v. Look, I'm going to be honest. Let's just use our differential equation solver to do this quickly as we can. So let's do that. So go menu, go into calculus, go down to differential equation solver. So what's our equation? Well, our equation in this case is going to be it's v dash is equal to so v squared plus 1 divided by v. So that one. What's our independent variable? So what is the thing that we are like changing? And that's the x value. And what's our dependent? What do we want? So like what's the output? It's our velocity, so it's our v. And what's our condition? Well, we have a condition that when v of 0, so when v of 0 is actually equal to 2. Writing this whole equation, we get this, and we press enter, and we get this beautiful equation. And yeah, so this is our displacement, this is velocity, and we know we want to find the displacement when the velocity is 3. So if I take this equation and say when x is equal to 3, and we want to solve for the velocity, we get 2 velocities. Oh, what am I doing actually? Sorry. We want to calculate the displacement when the velocities are 3. So when v is 3, and we want to solve for answer comma x. So x is just half of natural log of 2, which is c. Is that right? Perfect. Question 18. Let x be a random variable with a mean of this and a standard deviation of 4. Let y be a random variable with a mean of this and a standard deviation of 2. If x and y are independent random variables and z is this, z will have a mean and a standard deviation of what? A nice typical question. So if we want the expected value of z, we want the expected value of x minus 2z, 2y. And, using a formula sheet, this just becomes x minus 2y. So what's our expected value of x? We know that is 5 minus 2, 3. So that will be negative 1. So we can cancel out c and d. What's our expected... now we just need to find the standard deviation, which, okay, we can do that by finding the variance of z, which would be the variance of x minus 2y is equal to the variance of x plus, this constant gets squared, so plus 4 variance of y. And what's the variance of x? Well, it's just going to be, 4 squared, which is 16, plus 4 times your variance of y, which is 4. Alright, is that right? I ran the variable with the mean of this instead of 4. Yep. So 16 plus 16, which is 32. And we take the square root of that to find the standard deviation, which will be 4 root 2. So 16 times 2, yes, 4 root 2. Which one would that give us? B would be the answer. Question 19. The petrol consumption of a particular model of car is normally distributed with a mean of this and a standard deviation of this. The probability that the average petrol consumption of 16 such cars exceeds the 13-liter 100 km is closest to what? Okay, so what we want to find is the probability that the average consumption of 16, so the n is 16 such that the cars exceed this much. So your mean exceeds 13. What's our... Okay, so we just need to find the expected value of our mean, which is just going to be the normal mean, which is 12. And we just need to find the standard deviation as d of x, your sample mean, which is going to be your normal standard deviation divided by the square root of the amount of actual cars, which in this case is square root of 16 is just 4. So we can write that as 4, which is a half. So we can rewrite this in terms of normal distribution. So we can write it as the probability that Z is greater than 13 minus 12 over half. So probably that Z is greater than 1 over half, which is just 2. So when Z greater than 2, let's use our calculator. Go on menu, go to probability distributions, go to normal CDF, 2 to infinity, where we're going to use the normal distribution. Press OK and we get this beautiful value. So that will give us C as your answer. The mass of a suspended matter in the air in a particular locality is a normal distributable mean of this per cubic meter and a standard deviation of 8 microcubic per meter. The mean of 100 randomly selected air samples was found to be 40 micrograms per cubic meter. Based on the 90% confidence interval, what is it? Okay, so the mean, the sample. So we know that, okay, your sample means 40. Your normal S is 8. Your number of people is 100. And we want 90% confidence. So just using our CAS, go on menu, go to statistics and go to confidence interval and go to Z interval. And we want to go to stats. Okay, well, we know that our our standard deviation is 8. Our sample mean is 40. Our number of people is 100, and we want 90%. Press OK, Control Enter. These are our C lower and our C upper, which gives us the option A as the answer. Okay, perfect, guys. Hope you guys enjoyed this video and learned something through this video. Please, guys, make sure to like and subscribe and share this video with your friends. I hope you guys have a great day and take care of yourselves. Bye-bye.